to I Teach Skills. I'm your AI instructor. Welcome to our session on Introduction to AI on Azure. Today, we'll explore how Microsoft's cloud platform supports artificial intelligence solutions through its robust tools and services. Now let's delve into the core components of Azure AI. Here's the key point. Azure provides a comprehensive environment with pre-built cognitive services that simplify AI development. Next, consider how Azure integrates machine learning tools to facilitate the creation of custom models. We'll look at various ways businesses can leverage these capabilities for innovation and efficiency. Finally, we'll explore practical examples illustrating AI deployment in real-world scenarios using Azure. Today, we dive into the introduction to AI and its applications within Azure. Now let's look at how artificial intelligence is revolutionizing industries by offering intelligent solutions that enhance efficiency and decision-making processes. Here's the key point. Microsoft Azure Platform serves as a comprehensive environment where developers can build, deploy, and manage AI models using scalable cloud resources. Building on that, Azure provides tools like Azure Machine Learning, Cognitive Services, and Bot Service to support various AI functionalities from data analysis to natural language processing. As we move forward, it's essential to understand the integration of these services within Azure to leverage their full potential. Topic: Introduction to Artificial Intelligence. Artificial intelligence, commonly abbreviated as AI, represents the simulation of human intelligence in machines that are programmed to think and learn. These intelligent systems can perform tasks typically requiring human intellect such as problem-solving, learning, and pattern recognition. Now let's look at the development of AI has been pivotal across various industries including healthcare, finance, automotive, and customer service, transforming how these sectors operate by automating complex processes and providing insights from data that were previously unattainable. Here's the key point. AI technologies range from simple algorithms to sophisticated machine learning models that can adapt over time through experience, making them increasingly autonomous and capable of decision-making. Artificial intelligence, AI, refers to software systems designed to exhibit human-like capabilities. These include visual perception, which enables machines to interpret and understand visual information from the world, text analysis, allowing computers to process and comprehend written speech recognition, where AI can convert spoken words into text or commands, and decision-making, which involves making choices based on data without human intervention. Now let's delve deeper into how these capabilities are implemented in real-world applications. In the realm of modern technology, three pivotal fields stand out: data science, machine learning, and a topic, artificial intelligence. Here's the key point. AI involves intelligent software applications and agents designed to mimic human-like decision-making processes. Now let's look at topic, machine learning, where data and algorithms are utilized to train predictive models, empowering systems to learn from experience without being explicitly programmed. Building on that concept, topic, data science, applies mathematical and statistical techniques to analyze and interpret complex datasets, providing the foundation upon which both AI and machine learning thrive. Today's focus is on how artificial intelligence can enhance the software development process. As we delve into this topic, it's crucial for engineers to understand not only coding languages like C#, Python, or Node.js but also the intricacies of model training and inferencing. Additionally, they must be adept at consuming APIs, whether through RESTful services or SDKs. Another pivotal area is DevOps, encompassing source control and CI/CD practices. Now let's look at how probability and confidence scores play a role in AI systems, ensuring that engineers grasp their significance for model accuracy and reliability. Building on that, we must also emphasize the importance of responsible AI and ethics, as these are foundational to developing trustworthy AI solutions. In examining the principles of responsible artificial intelligence, we focus on several core considerations that guide ethical AI development and deployment. Firstly, fairness in AI systems ensures unbiased decision-making processes, crucial for equitable outcomes across diverse populations. Now let's look at inclusivity, which is about designing AI technologies accessible to all users, regardless of their background or abilities. Here's the key point. Reliability and safety are paramount to maintaining user trust and ensuring that AI operates predictably under various conditions. Transparency follows closely as it involves clear communication about how AI systems function and make decisions, fostering an environment of openness. Privacy and security must also be rigorously upheld to protect personal data and prevent misuse. Lastly, accountability is vital. It ensures there are mechanisms in place to hold developers and operators responsible for the consequences of their AI systems. Today, we are delving into how artificial intelligence, AI, is implemented within Microsoft's cloud ecosystem, specifically Azure. Azure offers a suite of AI services designed to help developers build intelligent applications seamlessly. Topic: AI services in Azure. Here's the key point. Azure provides comprehensive tools for machine learning, natural language processing, and computer vision. Building on that, Azure Machine Learning is one such service that enables users to create, train, and deploy models with ease. Topic: Azure Machine Learning. Now let's look at how these services integrate with other Azure offerings, like AI-powered data analytics in Azure Synapse Analytics or the use of cognitive services for speech recognition in Azure Cognitive Services. The Azure Machine Learning Cloud Platform provides an integrated environment for developing, training, and deploying machine learning models. This comprehensive solution allows you to manage the entire lifecycle of your ML projects seamlessly. Now let's look at how it facilitates creating machine learning solutions with ease. Topic: Creating solutions. Here's the key point. Azure streamlines model development by offering tools like automated data preparation and experiment tracking, making it easier to build sophisticated models quickly. Next, we'll explore the platform's capabilities for handling experimental data efficiently. Topic: Experiment data. It offers robust tools for data management, ensuring that you can focus on insights rather than infrastructure. Here's a key takeaway. Azure allows researchers and developers to track experiments easily with built-in data versioning and comparison features. Finally, let's discuss model deployment, which is crucial for translating your work into real-world applications. Topic: Deployed model. The platform simplifies deploying models in the cloud or on-premises environments. Here's the key point. Azure Machine Learning supports various deployment options like web services and batch processing, enabling flexible integration with existing systems. Today, we'll delve into the comprehensive suite of Azure's cognitive services, which offer a range of prepackaged AI capabilities that can be seamlessly integrated into your solutions. Now let's explore the language and speech services first. These include text analysis, question answering, language understanding, and translation features. Moving on to vision services, you have access to tools for image analysis, video analysis, image classification, object detection, facial analysis, and optical character recognition. Additionally, Azure provides decision-related capabilities such as anomaly detection, content moderation, and personalization. Building on that, the Azure Applied AI services extend these offerings with specialized solutions like Form Recognizer, Metrics Advisor, Video Analyzer, Immersive Reader, Bot Service, and Cognitive Search. Each service is designed to enhance your applications with state-of-the-art AI technology. Today, we'll delve into the Azure Bot Service, a cloud service designed to deliver comprehensive conversational AI solutions. Topic: Azure Bot Service. This platform enables developers to create, deploy, and manage intelligent chatbots across various channels with ease. The versatility of Azure Bot Service allows for seamless integration into multiple communication platforms like Microsoft Teams, Slack, Facebook Messenger, and more. Transition. Now let's look at the key benefits of using Azure Bot Service. Topic: Key benefits. Firstly, it provides a unified interface to manage all bot-related activities, which significantly simplifies the development process. Additionally, its scalability ensures that your bots can handle an increasing number of interactions without compromising performance. Transition. Here's the key point regarding integration flexibility. Topic: Integration flexibility. Azure Bot Service supports numerous channels, offering developers the freedom to choose where and how their chatbots engage with users. This capability empowers organizations to maintain consistent conversational experiences across different platforms. Today, we delve into the realm of Azure Cognitive Search, specifically focusing on its capability to enhance search and knowledge mining through AI-enriched indexing. At the core of this functionality is document cracking and field extraction, which are crucial for parsing unstructured data. Now let's look at the data AI enrichment pipeline, a critical component that transforms raw documents into searchable indexes by integrating various AI services. This process involves multiple steps, including OCR for text recognition, language detection, and content classification, to name a few. Here's the key point: indexing in Azure Cognitive Search isn't just about storing data, it's about making it intelligible and easily retrievable through sophisticated AI-driven techniques. By leveraging these methods, businesses can unlock powerful insights from their unstructured data repositories. To begin with, when considering the predictions made by a machine learning model, it is essential to understand that they are typically probabilistic values based on correlations found in training data. These models do not provide absolutely correct values. Rather, they generate estimates grounded in patterns discovered during their training phase. Now let's delve into how a trained model can be utilized within an application. If a data scientist has leveraged Azure Machine Learning to train a model, it can be deployed using Azure by publishing the model as a web service. This approach allows your application to access the predictive capabilities of the model seamlessly. Moving on to another scenario, suppose you wish to index and search through a collection of text documents from a mobile application. For this purpose, Azure Cognitive Search is the appropriate choice. It specializes in creating indexes for content that can be efficiently queried and integrated into applications. Welcome to our session on developing AI apps with cognitive services. Today, we'll delve into how you can leverage Microsoft's suite of tools to create intelligent applications that enhance user experience and drive efficiency. Let's look at the core components of Azure Cognitive Services and understand their functionality. Here's the key point. These services provide pre-built APIs and SDKs for various AI capabilities such as vision, language, speech, and decision-making. Moving on, we'll explore how you can integrate these into your applications to deliver robust AI features without needing deep expertise in machine learning. Cognitive Services offers a suite of AI-powered tools designed to enhance enterprise applications. Now let's delve into how these services can be integrated and utilized in various business scenarios. Starting with text analysis, cognitive APIs enable enterprises to extract insights from large volumes of unstructured data. Building on that, natural language processing (NLP) capabilities facilitate improved customer interaction through chatbots and virtual assistants. Here's the key point. Computer vision technologies allow for advanced image recognition tasks, boosting efficiency in areas like quality control and surveillance. Further exploring the impact, speech services offer real-time translation and transcription, enhancing communication across global teams. To wrap up our discussion on enterprise applications, emotion detection can be leveraged to better understand customer sentiment and tailor experiences accordingly. We'll begin by understanding how Microsoft Azure's cognitive services empower applications through artificial intelligence. These services provide pre-built AI models to enhance apps without requiring deep expertise in machine learning. Key offerings include vision, speech, language, and knowledge solutions. Let's delve into the vision service first, which enables tasks such as image analysis and facial recognition, making it easier for developers to incorporate complex visual processing capabilities into their applications. To efficiently utilize Azure's cloud platform, we start by provisioning cognitive services resources. These can be either single-service or multi-service resources. Topic: Multi-service resource. A multi-service resource allows access to multiple Azure Cognitive Services using a single key and endpoint, while also consolidating billing for the services you use. On the other hand, topic: Single-service resource, such as language, provide access to a particular Azure Cognitive Service with unique keys and endpoints for each service created. This option lets you take advantage of the free tier to explore the service's capabilities. Furthermore, it is important to note that some services demand distinct resources dedicated to model training and predictions. In this discussion, we will delve into the essentials of connecting services via endpoints, authenticating with keys, and understanding the significance of location. Starting with endpoints, these are crucial as they provide the URL where a service can be accessed, which is necessary for most SDK clients to consume the service effectively. Now let's explore keys. Both types serve the purpose of authentication, ensuring that only authorized users can access the service. Building on that, location pertains to the Azure data center where your resource is provisioned, a critical aspect required by some SDK clients to ensure proper connectivity and compliance with geographical regulations. In today's discussion, we focus on cognitive services REST APIs. These are designed to process HTTP requests submitted by clients to a resource endpoint. Each request must include a key specified in the header for authentication purposes. The input data is formatted in JSON and follows a specific schema that varies depending on the service and method being utilized. Upon processing, the service returns a response, also formatted as JSON. Let's delve into the cognitive services SDKs, which serve as runtime libraries that abstract REST interfaces. Each service offers multiple SDKs to support various programming environments including .NET, Python, Node.js, Java, and others. When a request is made in JSON format, it can be processed across these platforms. Similarly, responses are handled effectively within the chosen environment, showcasing versatility and integration capability. To effectively leverage Microsoft Azure Cognitive Services, the initial step involves provisioning a resource. This process can be accomplished through various methods, including utilizing a REST interface or an SDK. Provisioning ensures you have access to the necessary computational power and services tailored for AI applications. Once provisioned, users can interact with cognitive services using either direct HTTP requests via a REST API or more abstractly through software development kits (SDKs) in supported programming languages. These methods offer flexibility depending on your project requirements and technical proficiency. Cognitive services play a pivotal role in enhancing enterprise applications by leveraging artificial intelligence to deliver intelligent features. They enable businesses to incorporate advanced capabilities such as natural language processing, computer vision, and speech recognition into their existing systems without the need for extensive AI expertise or resources. Now let's look at how these services are specifically applied within different types of enterprise applications. For instance, in customer service platforms, cognitive services can be used to create chatbots that understand and respond to user inquiries with remarkable accuracy. Here's the key point: by automating routine tasks, businesses can reallocate their human resources to focus on more complex issues, ultimately boosting productivity. Moreover, in retail environments, these services power intelligent recommendation engines that analyze customer data to provide personalized shopping experiences, thereby enhancing customer satisfaction and driving sales. When securing cognitive services, it is crucial to regularly regenerate keys to maintain access protection. To prevent service interruptions during key regeneration, apps should switch between two keys, switching to key 2 while regenerating key 1 and vice versa. A secure method for storing these keys involves using Azure Key Vault. Here, the app accesses the cognitive services resource by retrieving a key from the vault. Additionally, an alternative approach is for apps to utilize a service principal as a managed identity to fetch keys directly from Key Vault. This setup leverages the service principal ID to enhance security and streamline access. In today's lab, we're focusing on managing cognitive services security by handling authorization keys effectively. To ensure secure key access, we leverage Azure Key Vault. Now let's look at the components involved in this process. First, it's essential to understand how authorization keys are managed and why they play a critical role in securing cognitive services. Here's the key point: using Azure Key Vault not only secures your keys but also simplifies their management by centralizing access control and auditing capabilities. Next, we will explore step-by-step guidance on integrating these components within your cloud infrastructure. Monitoring cognitive services involves ensuring that the right team receives notifications when issues occur. Metrics are numerical values that help in alerting, as they are collected at regular intervals and stored in a time series database. Diagnostic settings provide detailed diagnostics and auditing information. Logs contain time-stamped records of changes to resources and often include text data, though numeric values can be present too. Alerts in Azure Monitor arise from role-based configurations. The destinations for diagnostic outputs are primarily Log Analytics Workspace, Event Hubs, and Azure Storage. We are going to focus on configuring alerts and visualizing metrics within the Azure Cognitive Services Lab. Topic: Configuring alerts. Initially, setting up alerts involves defining thresholds for specific metrics that, when exceeded, trigger notifications. This is crucial in maintaining system performance and ensuring timely responses to potential issues. Here's a key point: alerts help preemptively identify problems before they escalate. Handwritten _note: setting alerts involves specifying metric thresholds. Next, visualizing these metrics provides an intuitive understanding of your service's performance over time. Graphs and dashboards can illustrate trends and anomalies effectively, allowing for better decision-making and system optimization. Here's the key point: visualization aids in interpreting data patterns clearly. Handwritten _note: visualizations convert raw data into interpretable formats. These combined approaches enable proactive management and improvement of cognitive services within your application environment. Introduction: cognitive services can be efficiently utilized through containers. These containers are available for a variety of commonly used cognitive service APIs, allowing developers greater flexibility and control. You can deploy these container images across several platforms including local Docker hosts, Azure Container Instances, Azure Kubernetes Services clusters, among others. This deployment model allows more control over the data that is sent to public cognitive service endpoints such as mc@microsoft.com/azure-cognitive-services. Even though containers provide a level of abstraction, it's important to note that usage metrics for billing purposes are still sent to your cognitive services resource in Azure. The client application interacts with the container instance, sending data and receiving responses accordingly. Despite running within a container, you will need a cognitive services resource since the container must communicate with it to relay billing data back to Azure. Finally, remember that after deployment, the cognitive service container image resides on your chosen host. In today's lab, we'll focus on deploying and running a container using Azure's cognitive services. This practical exercise will guide you through the process of setting up a container to harness powerful AI capabilities locally. Firstly, ensure that Docker is installed and running on your machine as it serves as the foundation for managing containers. Next, acquire an Azure Container Registry, ACR, where your cognitive service container image can be stored securely. Now let's delve into deploying a container from ACR to your local environment. Begin by pulling the appropriate container image using Docker commands. Here's the key point: authentication is crucial, so make sure you have the necessary credentials for accessing your Azure resources and Docker registry. Once the container image is on your machine, initiate it with a docker run command, specifying required parameters such as environment variables that include your cognitive services subscription keys. Building on that, observe how the container runs tasks in real time. You can interact with its APIs to test its functionalities, which might range from text analytics to computer vision, depending on the cognitive service used. In conclusion, this exercise not only familiarizes you with deploying and managing containers but also demonstrates leveraging cloud-based AI models locally for efficient development workflows. Topic: Access control. In order for client applications to access a cognitive services endpoint, they must specify a valid subscription key associated with the Azure resource. It's important to note that user credentials such as username and password are not typically required for this process. Contrary to some assumptions, anonymous users do not have default access rights. Proper authorization is necessary. Topic: Monitoring usage. To keep track of how often your cognitive services subscription keys are accessed, you might consider creating an alert specifically for your resource. This allows for monitoring and ensures that any unusual activity can be addressed promptly.